Very good morning to all of you. Let's start new topic. So we have covered the most important part of the course, without which security in this world of internet is not possible. That is crypto. And we'll touch upon crypto once again when we'll study Bitcoin, that is a cryptocurrency, okay, and blockchain. So the question that you can ask is that how crypto is connected to Bitcoin. Okay, what is the role and so on. So that will cover towards the end of the course. Okay, before that, we'll look at some network security, right? The security in internet world. So okay, so now let's discuss in very brief, uh, you know, the concept of security or how OS provides security. And I know that most of you have not done the course on operating system. In fact, I would think none of you have done because OS course is not offered in your university. So we will start with the basics, right? Before that, this is from today's newspaper. You know, this war that's happening between Israel and Palestine. Well, this is not regular war. These are kind of invaders or terrorists because they are attacking on women and children and public, right? The war actually happens between two armed forces. But anyway, we call this as a war. Okay. And then what is the role of cyber security in that? That's very important because both parties or both countries or both organization, whatever, starts doing cyber war because, you know, in today's world, it's not just war that happens between using, you know, whatever conventional means, explosive bombs and so on, so but also on cyber, right? Okay, so if you can take out all the money from the country, or you can take out some money, or you can destroy, for example, disable banks and power plants and so on, then that's also part of strategy, right? Okay, so your role in future will be, you as cyber security expert, if you decide to take up this area or branch, will be very important. Now, related point from this is that there is a great shortage of cybersecurity professionals in the world today. So, any one of you who wants to pursue further research or work in cybersecurity will get jobs easily. Okay, so today we will look at the concept of OS and how OS provides and how we can provide security to OS and how OS provides securities. Okay, so how many of you know what OS is? Can anybody tell me what is OS? Anyone? You are all using OS, right? Where are you using OS or operating system? Yeah. See, I need answers.
So mobile phones, laptop, computers.
Excellent. Everywhere, right? Wherever there is a computer or computing, there will be some form of OS. It can be embedded, very small control software, which is again operating system, kind of operating system. It could be even, for example, IoT, very tiny, small devices that will also require control because hardware alone cannot do the job. Okay, very good. So now operating system is there everywhere. And so let's look at what operating system is, what is the main role, and then we will look at what kind of security it provides to processes and what security it requires. Okay, so of course, you know, this is a full-fledged course. Operating system and security is a full 3 credit course, even more. So it's not possible to go into details into this, although I would love to cover more topics on OS because very interesting, but we don't have time here, right? So let's look at what we can do in this class. Okay, before that, when I have written the word here, the internet is lovely piece of work, right? uh, why it is so lovely? Why is it so great? It's the greatest technology, I would say, that has come out and that's helping all of us. What is so beautiful about internet? Anyone? You are born in that era, bhaiya. I am not born in that era. I mean, I got introduced to internet very late in life when I was almost like 28, 29 years old. Okay, it has of course given me many jobs. Okay, but the why it is such a great, I mean, we are using internet, that this kind of teaching was not possible 30 years back, even 20 years back, even I would say 10 years back, when internet was not so popular and this kind of apps were not there. So what is, and communication has been growing for last 2 centuries, right? Radio communication has started even before World War One, around 1900, year 1900, and so on and so forth, right? And telephone came around that time, and then there was a TV, then the radio channels, satellite communication. Then data communication came in the form of asynchronous, or not, before that there's a T1 E1 lines which still exists, SDH, and then we had many other technologies, Sonet, and then came frame relay, then came ATM. Of course, in between there was satellite communication, SATCOM, okay, and so on and so forth. Radar, these are technologies I read when I was doing bachelor's degree or master's degree. So what is so beautiful about internet? So these technologies existed, right? Even PSTN still exists. Why PSTN phones, or we call it pods, are very popular. Even at homes you will find this, right? On offices and your institute you will find pods, which is landline phones. What was so these were, what is so unique about internet? So these technologies existed, right? All these technologies that I mentioned. You think about it, na? Only then you can learn. What is so unique about internet? All of you have been using since you are born. I guess none of you are more than 25 years old, right? Maybe 16, 17. I want someone to answer this. No? What is so good about internet that it became the de facto communication technology, and it's just doing wonderful job of connecting the world, and the jobs that you are getting, that you will get in future in the country, this country, is primarily because of internet. Had internet not been there, it's very unlikely you would have got job of software engineer. Very unlikely. You still would have, some communication technology would have been there, but you wouldn't have been able to see the Netflix or whatever one day matches are happening on your mobile. So what is so beautiful about, see, all these applications we know, but you are engineer, right? You should know what is so good about internet. And I would like you to think about it. Okay, we'll come to that later if you can't answer it right now. what is the greatest artifact of human civilization? What is this? What do you see this as? It's not picture of universe, right? Okay, this is what we call it the internet. This gives a connectivity. This is how internet is connected. Okay, this is the internet, and it connects everything. Every device that you have, you can connect through it. You know, you can look at devices or something like car or mobile phone, your desktop, wristwatches, IoT devices, you know, mainframes or large machines, cloud, and so on and so forth, right? It connects everything. So there must be something beautiful about it, right? You can do video communication, you can do voice communication, you can send transfer data. Now compare this with pods, right? Plain old telephones, right? That you have at home. Possibly some of you may have at home. Okay, what is this? Was designed only for voice. That too for what is the bandwidth of analog channel? 4 kilohertz, right? Approximately. It's meant only for that. You can't do anything apart from voice communication ports. Of course, you can convert one of the channels into digital channels by using some modem and then do basic communication. That's what I did in the beginning, right? Getting only 1 kilobits per second or something like that. Okay, all right. So this is the one that connects the whole human civilization. Almost everybody has access to this, right? Everyone, even you can see even poorest of the poor possibly will have some kind of internet connectivity or other. Okay, all right. So now we can see the internet has grown from started from 1969 and finally it took shape sometimes in mid 90s, and then HTTP came, the web technology came, and web www came, and then it has started. See, initially it was only for scientific community. I mean, I used Ethernet. Sorry, I used email first time in 1986 when I was doing PhD at IIT Delhi, and since then, that time, of course, internet just started beginning is importance and use all over the world, and now today then it has exponential rise, and you can see today almost like 70%, close to 70% population has internet access directly. A number of internet connections would be more than human population. Okay, but almost everyone is touched by internet in some way or other, although may not have direct access, when they may not have mobile phone or laptop to use, but some way or other they are all using this. This is the only technology I can see, of course, apart from computers in some form or other, that has touched the whole civilization. It has improved the productivity significantly. It has helped people to become aware. It has made world look flat. Okay, and this has given access to knowledge, information, jobs, etc. to everyone in the world. Okay, now let's look at other aspect. Okay, of course it works on all kinds of devices that we have seen earlier. Let's look at how computing has grown. Okay, in 19 when I sometimes in 70 I started working from, first time my access to big machine was DEC 20 in Roorkee University, and then we used to get just 30 minutes of terminal time every alternate days, right? So this kind of large computer and number of people who had access to this was one in almost like 1 million. That too, this is US data, right? If you see the world, it could be much bigger ratio, right? Smaller ratio, one in maybe 10 million or something like this. And then came mainframes, then and we can see the ratio started changing, it becoming more accessible. Then came mini computers, then came workstation, then came PCs, then came laptops, then PDAs, cell phone, IoT, and so on. Now we can see almost ratio is reversed. In future we will have every human being will have about 1,000 different ways of doing computing, right? Almost like 1,000 computers or 1,000 computing devices every person will have. There's a prediction, right? And IoT right now, even I am very ordinary person. I am having more than 10 devices for myself which are internet connected. Okay, so there's a Bell law that every new computer class comes a new class of computers, like all these are the classes, you're part of the classes, every 10 years. Every 10 years there's significant change in technology, and a new class of computer comes up. Okay, and you can see here what applications we can use it for. Now let's look at other aspect. How complex a computer is. Have you ever tried to assemble computer? Of course we used to do that because we used to save money, but do you think do you ever looked at what is inside computer? Okay, there are a lot of things inside computer. Of course you have hardware, and when we say hardware, it's not just only, we will say motherboard, or is a compute is only processor, right? It has nowadays multiple processors. Even your mobile phone has 16 processors. Okay, it's not just single processor. Then there is a memory, random access memory. It's DRAM, right, for example. And then you have cache memory, then you have IO devices, then you have secondary memory, and so on and so forth, right? Okay, and then everything has different characteristics. For example, there are two kinds of caches, L1 cache, level 1 cache, and level 2 caches. Cache is a very fast memory which is very close to processor. The whole idea is to match the speed of processor with the speed of memory, such that there is no wastage of cycles, CPU cycles, right? So when you can, whatever laptop and desktop you have, just look at the configuration, right? Look at what it has, right? And then you can find all these components. And then access time for cache, L1 cache is about half nanosecond. Okay, L2 level 2, basically if you see this as CPU, then there will be L1 cache, then L2 cache, then there will be RAM. I'm telling you about memory hierarchy, right? Then there's a hard disk, or now flash drive, right? And as you go down, access time goes up. So what you do is that you try to move everything as much as possible which CPU is using at the time to L1. Okay, so as you go down, you can see access time goes up, right? Okay, for example, if your hard disk, then it will take almost like 10 million nanoseconds. Okay, and you have to send a packet, IP packet, then it will take 150 million nanosecond. Okay, so starting from 1 nanosecond kind, the time required to do an operation goes up to 150 million times. So these are all sources of complexity in computers, because now different components behave very differently, both in functionality and timing. Okay, and there are now hardware is becoming complex. You have GPUs, multiple processors, 16 processors is very common, and GPUs will have almost like times 0 to 4 or even more plus processors, and each processor will have something inside. All that we have discussed, this kind of things, right? Okay, now the question is that who is going to manage all that? Who is going to manage this kind of complexity? Suppose you're asked to manage, 10,000 workers, and each worker works at very different pace and is doing different tasks, and you are the only manager. How do you manage all that? 1,000 plus helper or workers working for you, and they are working in different speeds and doing different operations, or maybe some may be doing some same operations, and some may be corrupt, some may not work. How do you manage all that? And yet you may want highest, your expectation from you is that you give efficiency. Okay, so it's the role of OS that manages all this complexity. Have you ever bothered about what is your RAM size? What does it do? How does it store? How does it your when you say print, your data goes to a printer or some file. Are you bothered what file looks like? All you want is printout. Okay, and you say let email go, right? Email goes, right? But how does email go? Right? I mean, at the end, bottom end, there will be Ethernet drivers, Ethernet card. From that, where is it going, and how is it that this data that your application is generating is going into get in the packet format? And who is all doing that? Who is scheduling that? Because your computer is doing 100 other things. Okay, all that is the role of OS. It's very, very interesting technology. Okay, because technologies keep going up, and then users should not have view of that technology. Otherwise, life is extremely. If you are asked that your program is running, now you have to load this program into a particular part of the memory, and then you'll have to clean up the memory, and second program will run at second part of the memory and make sure that one program doesn't interfere other. Who's going to do that? You're not going to do that. It's OS who does it on your behalf. Okay, so it manages sharing of resources among multiple applications. Its key building blocks are processes, thread, concurrency, scheduling, coordination, address space, protection. It protects users. It protects one process from another process. It isolates one process from another process. It also provides sharing of resources, security. It does communication. It supports communication protocols. Then it manages persistent storage like your flash or hard disk, and also it manages RAM, random access memory, and so on and so forth. Right? Okay, and interacts with all devices. All right, so that's what it does. Now let's ask, what is an operating system? Is it hardware or is it software, or it is hardware plus software? Okay, I'm asking any one of you. Please answer. If you know, then you must answer. If you don't know, say we don't know. Hello.
Sir, operating system is essentially a piece of software, but it uses hardware support to perform certain actions like hardware support in case of trap handling, etc.
Yeah, very good. Very good. It's actually is a software and it runs over hardware. Of course, it is supported by hardware, as you said, right? It's just software. Okay, it's just software, nothing more than that. Okay. Now the question I am asking, next question I can ask you, which of course I mean subsequent slide. You have single processor. Okay. Now this software, you say OS is software, so it's running on it. Okay, now you have another application that it wants to run on the same processor. Do you mean to say that OS doesn't run all the time? Does OS run all the time or it doesn't run all the time? Yeah, please answer.
Sir, when the particular application is running, at that time the CPU resources are allocated to that particular process only. But because of a timer interrupt, we can have a context switch. That, and in
Wow,
case of
very excellent, excellent, excellent. So basically, OS or OS routine that's running is also a programmer process, right? Okay, so the hardware, for hardware, whether it's at one time, if it's a single processor, it can either run OS or it can run any other application. So it means the answer is that OS doesn't run all the time in any machine, but for you, you get the feel that OS is running all the time because computer works at very high speed. Say for example, when you're running shell or you want to read a file, okay, then OS starts running. But when you're not doing anything or periodically, it gives time, the processor gives times to other processor applications to run. Very good, excellent. So operating system is nothing but something that combines these two. Operating, it manages multiple tasks of users or set of internet, because a large number of components are there, these are to be managed. Okay, so it's especially a software that provides application software access to hardware resource. Note that whatever app you are writing or whatever app you are running, for example, I am running PPT and also running WebEx, and hundreds of other programs are running right now at this point in time on my machine, right? Okay, all of these have to go through OS to access hardware. Well, ultimately, these applications will run here. Okay, but it has to, the OS is the interface. It means that OS will, when we say is running, who will allocate CPUs, right, for that particular application number one, because I am running now 100 plus applications. So every application will get time. So it has to allocate resources in CPU. Okay. And then it has to put that program into main memory, RAM, in some form such that it can execute. And so on and so forth. There are hundreds of things it has to do, and it all are done through OS. You can't run your application directly on the hardware. Okay, even if you want to develop your own very dedicated, machine for one particular, even then you have to have some control program in between. Okay, all right. So so OS now. Other thing is that what kind of view it provides to you as a user. What you see is a file. So what you see is when once you just double click, your program starts running. Okay. Okay, so it provides, even for programmers, app programmers, it provides an abstraction. It provides, so all your hardware and etc., even part of OS is black box to you. And you keep changing hardware in between, okay, but it's not visible to application. So it just provides one interface. Okay, so it provides abstraction. It provides protected access to shared resources. I mean, there can be one of these app could be a malware virus, right? And it may want to access the memory that your application is using. So then OS has to protect that, right? It provides security and authentication. It provides communication among logical entities. Okay, so this is a running program. Okay, and it uses this processor. Processor will have registers and so on and so forth, and ALU and so on. If you have done the course, then you will learn about it. You would have learned about it, otherwise you will do computer architecture course sometime or other if you want to understand how computer works, right? And there is a memory. When we say memory in general, we call it main memory or RAM. Okay, so application comes here. Okay, of course there is a cache in between, and there are page table and TLBs. You will learn about it in case you do this course. And then there's secondary storage like your hard disk or flash drive. Okay, and then IO. IO, for example, with the internet or through modem or Wi-Fi router or display or hard disk, all these comes, sorry, some other device, mouse, etc. These are all connected through IO, which is slow in nature, very slow in nature compared to this access of processor to data content through cache. Okay, now all these are for any processor. There is instruction set architecture. Okay, now this instruction set architecture provides abstraction to your applications. So your applications can, as a programmer, you can write programs using this ISA, instruction set architecture. Okay, for example, for Intel processor, there is different instruction set architecture. For Mac processor, of course, which is, or ARM processor, is a different instruction set architecture. For Power PC, it could be different, and so on and so forth, right? So this instructions architecture provides interface. Okay, this is all right. So this is one thing, right? But lot of activities here that's happening here also needs to be abstracted. Okay, so now if, for example, what we have done is, of course, programming perspective, this ISA, but writing into storage, for example, when you write a file into your hard disk, or when you are running a program, all these things are managed by OS. So OS does memory management, IO management, CPU scheduling. That is how CPU must be shared across many. Communication support, multitasking and multi-programming. There can be multiple processes running at a time, and all of these must be given time in the CPU in some way or according to some scheduling algorithm. Okay, that comes under multi-programming. So basically, multi-programming, multiple processes or programs are running in a system, over a period of time. Okay, then it manages file system, multimedia support, user interface. Now, file system is also very interesting. What is a file? You just don't put zeros and ones simply as you get. For example, I have JPEG picture, right? You have a camera, video camera, or nowadays any camera, your mobile phone, and what you get is JPEG picture, right? How is it different? JPEG is different from, say, for example, your PDF or docs file, right? What is the difference between all this? Is this, of course, zeros and ones, but how these are to be interpreted? Is there some header here that will say how to interpret rest of the bits and bytes? Okay, yes. So file is not just something very plain and simple and so on, but it has also metadata or some data that defines what kind of file it is. Of course, I mean, you can learn this in OS course. So what OS does is that of course, we have seen ISA here, which, through which you can do programming. Like, for example, it will have some instruction like store from A to B or move data from register A. I'm just giving very hypothetically A to B and so on and so forth, right? So these kind of assembly language instruction are defined by ISA. Okay, or multiplication, add, all these things come under ISA. But apart from that, something that's really needed is OS to manage all this, right? in efficient, secure, and user friendly way. Okay, so it should give some abstraction to users. If printing or storing a file itself requires you to do whole lot of programming, then you will never use computers. So OS gives that abstraction. Just by moving cursor, you can store a file, right? So now it means that now it must give some interfaces or abstraction or APIs, anything you can call, through which a user can access this system in well-defined way. Okay, so these are the interfaces provided, right? Okay, for example, threads, address space, files, sockets. Socket is required for communication, right? Okay, and processes. All right. And of course, what you have is user written program. When you write a program, you compile it, and then that compiled program uses these abstractions. Okay. Now note that user programs accesses the hardware through system library. Okay. System interfaces, right? Okay. System APIs. Okay, this is the same thing. Okay. Now here, when we run a process, assume that there are two programs, program 1 and program 2. Okay, and program 1, when you bring it to run, it becomes process. When running program is a process, we'll define process little later. This is a process 1 and this is a process 2. Okay, now note that there is only one hardware. So either and also let's assume only two are running. Process 1 and process 2 are running, and of course OS runs in between. Okay. Now what will happen when you are running, say for example, process 1, okay, this one. So basically your processor registers are loaded with correspondingly data, and your program counter etc. points to first location in memory and so on and so forth, right? Okay, and then part of the memory is RAM, part of the RAM is occupied by this program 1 or process 1 in some form. Okay, so this process now is running this program or this process. Okay, now there is also process 2, that's also part of this memory. Okay, but it's not running right now. Okay, now the question is that how do you isolate them? Okay, so initially processor is running here process 1, and then there's a context switch happens, because this process cannot be given time infinitely. So process 2 has to run, so now it moves to process 2. Now here there is, so now this thing will shift to process 2, okay, or a area corresponding to process 2. Okay, and what we see here is nothing but something that area of memory or RAM that process 1 can access. So P1 can access this area of RAM, P2 can access this area of RAM. So there is a separation between the two. Okay, now if process 2 wants to access area corresponding to process 1, that's not allowed. Okay, now there's a responsibility of OS. There are 100 such programs are running which converts into process. Then this process must be separately assigned areas, that's called address space. Okay, all right. Of course, I'm covering all these concepts very fast. Ideally, it should take one class each, but nevertheless. So responsibility is always is to protect one process from another process. So if this process 2 accesses area in RAM corresponding to process 1, then this is, if there is no OS, then this is allowed. Note that there is no OS right now, it's a blanked out. Okay. So if there is OS, then this is not allowed. If one particular process tries to access area corresponding to some other process, then there will be a page fault or segmentation fault or core dump. You would have come across this core dump. Okay. So this is the protection that OS provides. Okay, so now one of these processes could be malicious, or say for example virus. If virus can get access to any process, then virus job is done. The virus, what is a virus? Virus is also a process, right? And this virus must also be scheduled to run on a processor, right? So it's also process, right? It's also running. When it runs, it wants to access the area corresponding to some other process that should not be allowed. So basically OS provides this kind of protection. Okay. So now the same thing is coming here, that OS isolates one process from another process. And OS by itself protects itself, right? It isolates itself from other processes because OS is also a process. Although all of them are running on the same hardware. So that's the beauty of OS, that it protects one user from other user, and it also protects itself from malicious users or any users. Okay, any question? Okay, all right. This question we have already answered. We'll go. No, do you know the difference between program and process? Anyone, please? If you know, then I will skip. Yeah. Yashasvi, do you know it? Saurabh? Anyone? If you don't know, you say no. What is harm in it? Bhargavi? Are you there?
A program is put under execution, then it becomes a process.
Very good. Yeah, so why did you take so long? Even if it's wrong, just answer here. Just if it's wrong, what is there? I mean, we may not know. We don't. It's not necessary that we know everything, right? And it's good answer because you have not done the course on OSS yet. What you said absolutely 100% correct. A process is a program in execution. Okay, process is OS abstraction for execution. Is, for example, a sequential process is unit of execution, a unit of scheduling, and dynamic execution context. Okay, so basically, when you schedule onto a CPU or processor, okay, a process, okay, then so you schedule only processes. You don't schedule programs. Okay, and address, what is address space? Set of memory address accessible to a program. Okay, all right. So this is very important concept. Normally, I take 2 classes to teach address space concept, but we'll try to cover it quickly, possibly in the next class. So how do you create a process? Okay, So Alice is here and she is trying to create a program. She writes C program foo.c using some text editor. Okay. And then she compiles it. Now, have you ever seen what is the form of a.out or what is this? This is very different from compiled file, is very different from which is executable file, which you can execute, is very different from source file. Now, in the process, a lot of things are happening. For example, if you are using some libraries, then library code also come into picture. If this program is using 100 different programs or routines, then all come here. And then shape of this, the format of this is very well defined. It's called ELF format. At the end of this slide set, you will get ELF format, right? So always there is a very specific format of a.out file. And this is again, when we say file, it can be anywhere. It can be in hard disk or your flash drive. Okay. Now this is, and it has sections like instructions, which are machine instructions, data, within data it could be static data, and so on and so forth, right? And now this is, when this is loaded in the memory, the magic happens. Magic is that now in order to it to become processed in main memory, okay, space is allocated that corresponding to this one, and address is between 0000 to FFFF, which is the topmost, and the top part of course contain OS routines. Note that every process that is loaded in the memory, this program when executes, it accesses these in terms of, for address space or address for that area starts from 0000. It means that if there are 10 such processes, all will have this kind of structure. Now you may ask that in memory, how is it possible? Because addresses will vary from 0 to whatever at highest level. So we have something called virtual memory or address level translation, which will possibly we will study later. But nevertheless, look at this beauty that now this program is converted into this structure where there are instructions, there is data, there is a stack, and there is a heap. Now stack grows this way, heap grows otherwise. The stack contains variables. Heap contains dynamic data, right? In a program, dynamic data could be, for example, malloc. You know, at runtime you want some area, then that's called dynamic data. And for example, malloc on C will give you some memory location that you want. Okay, all right. So now this becomes a process, and of course this is part of processor. Your program counter tells you where in the process, which instruction the process is executing. Okay, all right. So now what do? You have a source code, you compile it, and this become in ELF format. For execute, we call it executable image. And when it is loaded in main memory, then this become process. So this program now becomes process. It has all these structures like stack, heap, data, machine, instruction. Of course, we are showing in a different direction. And then of course, OS code is always there. Okay. And this is the role which you can go by yourself. I mean, read it by yourself. So in order for process to become, so program to become process, OS has to allocate this memory that we have seen, this memory. What part of memory it allocates, that is OS choice. Okay. And then it has to open basic files and initialize CPU registers, and then give control. When this process has to run, then OS gives control to this process for execution. It means that now CPU can execute this particular process. Okay, all right. So now it means that OS provides protection and isolation. Right? Okay, because a process can access its own area. So if there are multiple processes, okay, I will there are multiple processes, each will have address space and each will be placed somewhere or other in main memory. And then if this is process 1, this is process 2, then process 1 can never access instruction here is, for example, read can never access area of process 2. Okay, all right. So this is the concept. Okay. Any question that you have? So next class we'll look at some of these address space concepts. Okay, how does it provide isolation and how OS provides security? Of course, this I wanted to cover all this, but we didn't have enough time today. All right. Any question? So this here it gives address space translation. I mean, in memory, your program always works in terms of zeros and ones. You know, when you refer an instruction, a program instruction refers to some data, it uses only addresses between 0 and some maximum address. But in main memory, actually, you know, it's a part of main memory. This actual address could be different. Okay, and then because this is using this kind of addressing here, it has to be translated into actual address. How much? So this is done by the concept is called virtual memory concept, or it change this, you know, 0 every process is 0 0 0 to FFF some max. This is to be converted, and this is called virtual address, is to convert it into actual address, which is called physical address, which is part of main memory, is done by a translator. Okay, all right. We'll look at some of these concepts later, and then we'll look at what we are trying to achieve through OS security. Okay, any question?